Hello, welcome to lesson 19. In this lesson, we are going to look at a photographic camera and then a prism binocular. Let's begin by looking at the photographic camera. So here we have a photographic camera, the diagram for a photographic camera. A photographic camera consists of the camera lens system, which focuses light from an object onto the film. And then the film is where the image is formed. The film is where the image is formed, and the shutter cuts off light where necessary. This one cuts off light where necessary, the shutter. That means that whenever because for the image to be very clear, there must be a limited amount of light entering at a specific time and then being cut off. So this shutter is used to cut off that light when we need to cut it off. And then also have what we call a stopper, this and that, or what we call the diaphragm. Now this regulates the amount of light incident onto the film. It regulates the amount of light incident into the film. That's the diaphragm. So that is the system for a photographic camera, and each of these parts has an importance in order for the image to be formed in the film here. So it is very important for us to know the function of each part, like the lens system which I've talked about, which focuses light of an object onto the film, and the film is where the image is formed, and then this shutter cuts off light whenever necessary, and then the stopper or the diaphragm regulates that amount of light incident onto the film. Now let us make a note. We need to note that chromatic aberration in photographic cameras is minimized by using a chromatic combination of lenses. That is one convex and the other concave, to form what we call a chromatic doublet. As we saw previously, we form what we call a chromatic doublet using a convex lens and a concave lens. So usually in photographic camera we minimize that by using a chromatic doublet. I'll just go back briefly. So in this lens system, what we do, we make sure that we modify this lens system to have what we call a chromatic doublet, and that will help us to minimize the chromatic aberration. And then also spherical aberration in photographic camera is minimized. Spherical aberration is minimized by use of a shield. We usually place a shield with a small hole in the middle and lenses of small aperture. So we usually place a shield with a small hole, that is a shield which consists of a disc and then with a small hole. The shield is in the form of a disc and has a small hole. That helps to cut off the marginal rays. And then also what we do, we also use lenses of a small aperture. So apart from using that one, we also try to use lenses of a small aperture to minimize spherical aberration. Okay, so that is about the photographic camera. Maybe let's go ahead and we look at the prism binoculars. So a prism binocular Remember, we looked at Prism binocular as one of the applications of total internal reflection, and we said we would discuss it later on. So here we are going to be discussing this Prism binocular, and we have to know that it applies mainly the principle of total internal reflection. Now let us see the diagrammatic representation of a Prism binocular. So here we have this as the objective, then we have two right-angled isosceles triangles, and then we have this eyepiece. So what we do is that these two right-angled isosceles triangles, that is, say this A and B, are placed between the objective and the eyepiece, with both being convex lenses. This eyepiece and this objective are convex lenses. Then we place these two isosceles right-angled triangles, we place them between the objective and then the eyepiece. Then one of these, that is B, one of these prisms, that is this B, is placed with its refracting edge, vertical. So this is the refracting edge. We place this with the refracting edge vertical, while the other, that is to say A, while this prism A is placed with its refracting edge horizontal. Is placed with its refracting edge horizontal. So that's how we arrange them. And then when we arrange them like that, this prism A will turn around the image formed. It will turn around the image formed because the rays move from the objective onto this prism A. So this prism A turns around the image formed by this objective in a horizontal direction. So to turn around the image in a horizontal direction, as you can see, turning it around in a horizontal direction, or what we call lateral inversion. So this one is going to invert the image formed by the objective laterally. It's going to invert it laterally. While this prism B is going to invert the image formed in a vertical direction. It's going to, then this B will invert it in a vertical direction. Then the image which has been formed, the image which has now been formed at this point, the image which has been formed by this, the image which has been formed by this prism after that vertical direction inversion, or after inverting the image from A vertically, then what you are going to have is that the image which has been formed is at the principal focus of this eyepiece. That image is going to be at the principal focus of the eyepiece, and it's going to be in the same way up as it was from the objective, as it was coming from the objective. So you realize that at this point these rays are going to be as they came after passing through the second prism, that is prism B. It will again be upright, just like it came from the objective. And also we need to know that it will be from the principal focus of the objective. So we shall get our original image just like it came from the objective, and then this eyepiece is going to form a virtual erect image at infinity. It's going to form a virtual erect image at infinity. Yeah, so that's how the prism binocular works. So just to repeat, the objective is where the light rays comes from, and then focuses light onto this prism A, which inverts it laterally or horizontally, and then to B, this prism B is going to invert the image in a vertical direction, and then the image is going to be formed at the principal focus of the eyepiece, which thus forms a final image at infinity. Let's look at the advantages of prism binoculars. One, it forms a final erect image. That is one advantage. It forms a final erect image, and then also it has a wide field of view. It has a wide field of view, and lastly, it has a compacted size, as we have seen in the diagram. It has a compacted size, so it can easily be moved, or it can easily be moved from one place to another. It's portable. So this is how this prism binocular looks like. Or it can be like this. Of course, this is, if I look at it from above, so this is the other way. So this is what you call a prism binocular. So it is also used for viewing distant objects. Yeah. Thank you for your attention. We meet in our last lesson.